Good evening, sir. I'm Divya from CSCA, and my roll number is 22211805116. Today, I'm here to explain your topic of applications on merge sort. But before going into the merge sort, let me just explain you what is actually a merge sort is. A merge sort is a sorting algorithm which is used in data structures algorithm. It is one of the efficient and versatile sorted algorithm that can be performed for various large data sets. So here is the picture where you can see how the Mozart is being performed. So coming into the topic, now let me just explain how this Mozart works. Mozart follows this divide and conquer rule principle, where it consists of three parts. The step one is it will divide the array into sub arrays, and then the step two is it will conquer the sub arrays. That means, what are the sub arrays that have been divided? There, arrays will be sorted until each sub array will contains at least one element, and then after all the sub arrays have been sorted, that all sub arrays will combine to form a single sorted array. Now, coming into the time complexity of this merge sort, time and space complexity. So merge sort has a complexity of big of n log n, which is suitable for this large data set, which is more efficient. Now coming into the space complexity, basically this merge sort takes an extra space of big of 1 that is constant. So the total space complexity of merge sort is big of n log n. Now, for the stability purpose, it is a stable sorting algorithm, making it preserves the relative order of equality elements. And then now coming into the applications of merge sort. So we'll be discussing the merge sort applications such as data sorting and then external sorting and distributed systems and so on. Now let us come into the picture of data sorting. So what is data sorting? The sorting will be performed on these large data sets where we can perform this merge sort. The first one is external sorting or external sorting. So what is external sorting means? Basically, when we have a large data set, these large data sets cannot be fit into this memory such as RAM. Now here we need to externally sort these data sets. So for that purpose, merge sort comes into the play, where externally will be sorted, that is using disk drives, etc. Now linker list. Linker list is the best example for this merge sort, where basically this linker list is a data structure where we cannot access the elements directly. Instead of we need to update the pointers and perform operations. The same merge sort will do. The same thing the merge sort will do. That means it will sort the linker list by updating the pointers. It is one of the best examples for this merge sort. Now coming into the parallel processing. Basically, what is parallel processing means? Performing multitasking simultaneously. That means if we have a thousand number of tasks, we need to perform it at the same time. Then here comes into the play of again merge sort. It will support this multi-processing, where we call it as parallel processing. And then coming into numerical simulations. Numerical simulations are such a thing, and it's a process where it will be generating a large data sets at instance of time to analyze to analyze or for analysis purpose. So at this time, merge sort comes into the play where it must be performed on it. Now, these are the four techniques, four applications for this data sorting. Now, coming into the more sorting, external sorting and distributor system. As we have discussed what is external sorting, the sorting will be taking place externally. Now, coming into these three applications, that is scalability, distributed system, and fault tolerance. Scalability, merge sort is highly scalable on large data sets. This algorithm efficiency makes it a popular choice for sorting large data, scale data in distributed and cloud computing environments. Now coming into the distributed system, as I have said that merge sort is actually based on a principle of divide and conquer, where it approach lends itself well to distribute processing, allowing for parallel sorting on multiple needs. Now, coming into the third one, that is fault tolerance. Fault tolerance is one of such process where any software or a processor can run, even though a failure occurs. That means, even though an obstacle occurs, it can run without any interruption or distribution. So Mozart has that capability of fault tolerance. That means it can adapt to an environment where it has failures, but yet it will be performing. This can be used in distributed system, ensuring data integrity and reliable sorting techniques. Now, coming to the next slide, we have Mozart in parallel and concurrent processing. So again, here we have four things, that is CPU parallelism, GPU acceleration, distributed computing, and cloud computing. So coming into the CPU parallelism, basically on our software, we'll be having a number of tasks that needs to be performed simultaneously at a time. So this will be handled by central processing unit, that is CPU, which acts as a memory unit. This central processing unit, uh, it actually has the number of cores. I mean, the number of tasks will be performed simultaneously depends on this number of cores that CPU have, and this will be handled by this merge sort. And coming into the GPU acceleration, GPU means graphic processing unit. That means it have more computations better than CPU, which is a traditional computing unit. Now, even this also, GPU acceleration, it leverages the massive parallelism of modern graphic cards. Now, coming to the distributed computing, Mozart can be implemented in distributed system with this input data divided among multiple computing nodes. So, you can see computing is such a technique for the storage purpose. So here Mozart comes into the play. Now coming into the last one, that is cloud computing. Cloud computing is one of such a platform, even distributed systems. These are the platforms used for storage purpose. That means these are the platforms that can store that needs to be stored a huge amount of data. So in such situations, Mozart actually plays most important role here. That means it will handle this large data just by it will handle this large data just by taking the input data and then dividing it, and that means sorting it by the smart sort, and then giving it to this environments. So these are the applications that are discussed for the merge sort. One is data sorting, external sorting, distributed systems, and another is parallel processing and concurrent processing. Now coming into the conclusion, basically, Mercer is actually used in external sorting, data sorting, as I've said, and it is one of the most efficient, versatile sorting which can be performed on large data sets. Now, coming into the versatility, it is highly scalable on this large data set, um, coming from external sorting to parallel processing. Now, stability, it is highly stable sorting algorithm, preserving the relative order of equal elements. Now, coming into the adaptability, as I've said, merge sort can handle these failures. That means it can perform on a system that have fault tolerance. It can optimize for various computing environments. So these are the things that I've discussed. From the start, I can say that I have discussed what is merge sort and its time complexity, its space complexity, on what principles of merge sort will work, and what are the applications of merge sort, that is data sorting, external sorting, parallel processing, distributed processing, computing, etc. So these are the key points that I've discussed in this video. Thank you, sir, for giving me this wonderful opportunity. I sincerely thank you.